Hello. Let us get started. So, welcome today to my talk, which is called Motional Intelligence, about building smarter animations. My name is Nick Butcher, also known as Crafty. I'm an Android developer advocate where I specialize in UI design and development. So I've spent a lot of time on the main thread. I really quite passionately believe in animations, which maybe you do too if you're showing up to a talk named Motional Intelligence, somewhat kind of unintuitively. So I think that my slides should be updating. Hello? Anyone can help with that? Oh, there we go. Let's try that again. So I think animations are super important. I'm showing you here two versions of the same screen. On the left, we have animations enabled, and on the right, they are turned off. And I think when we think of animations, a lot of people think about adding delight or whimsy or some kind of polish to your application. But I really believe that while they can achieve those things, they actually have a really important role in usability, in helping your users to understand what is going on in an application. Whenever anything changes, whenever you move from one state to another, an animation can help tell that story, to take the user with you between those changes. So I think animations are really, really important for usability. But I feel like they're somewhat under threat at the moment. They're already hard enough to get past your stakeholders. They end up being the first things on the chopping block, right, when you are crunching on a feature. And I think they're somewhat under threat right now with some architectural changes happening in the Android landscape. By which I mean there is a movement towards how we architect our apps, where we have a source of truth outside of the view layer, which is holds on to the state of your application, and then publishes this state as some kind of UI model view state. It has many names. But the idea of this is some kind of simple data object which completely describes the state for your UI. Now, I'm not going to talk in depth about this pattern, but essentially your view model, presenter, whatever you call it, ends up publishing a stream of these states so that every time something changes in your business logic, whenever there's an action from the user or a network request perhaps comes back, it publishes a new version of this. There are many advantages to this architecture, such as being able to reason about the whole state of your UI at once, eliminating classes of bugs, or perhaps being able to test it. Like I said, I'm not going to talk about this today. There's lots of great resources about this. Look for unidirectional data flow, or MVI, or I quite like the state of state management by some guy called Jake, whose opinions are his own. But what I do want to talk about is how this has an effect at the other end of this pipeline, about how when we have this kind of architecture where we have a stream of UI models coming at us, what we want to do is have this very simple kind of binding function that takes this stream and binds it to our UI that we're presenting. I feel that this is kind of intention. This is the kind of tension I want to talk about today, that you have this kind of pure function almost, where given a UI state, bind it to your UI. It wants to be stateless. Given this, do this. Whereas animations, on the other hand, are inherently stateful. They're all about moving from one value to another value over time. So today, I want to focus in on this tension and talk about some techniques, some classes, some tools that you can use in order to kind of bridge these two worlds, in order to retain animations. Because like I said, I think they're important, and I don't want them to be thrown out with these improvements that we're gaining from our new architectures. So let's have a look at some of these problems and really understand what I'm talking about today. Let's talk about kind of a minimum viable UI here, where we have some kind of login form. And focus in here that on this interaction, that when the user hits login, I want to fade out that button and fade in some kind of progress indicator. So I don't want them just to blink in and out of existence. I want this to be animated to give a bit of a smoother experience. What might the UI model for this interaction look like? We can model it pretty simply, where we have a very simple data class, which has a couple of booleans representing our state. For my binding, to take this state and bind it to the UI, I'm going to use the Android data binding library. I'm using it here, but I don't want to mislead you that this isn't the only way you can do this. There's many ways you can bind this state into your UI. You can use simple functions, some kind of view binder class if you want to. I find data binding pretty useful for creating reusable binding adapters and eliminating a lot of boilerplate. But I want to be clear that this technique applies without the data binding library. You can use whatever you use in your applications. But in the data binding world, this is how it might look, where I'm going to be setting that UI model on my binding and then referencing fields of it from my layout. So here I am setting the enabled state and the visible state depending on some fields in my view state. So this isn't animated just yet. We can go ahead and instead write our own binding adapter, which is data binding's way of adding custom logic to this process. So here, let's create an animated visibility change in order to animate those changes. This is going to build upon a technique from George Mount from the Android framework team, who wrote a blog post, which I highly encourage you to check out. So if you haven't written a custom binding adapter, it looks something like this, which is essentially a top-level function which takes the view and the properties that we declare in the attribute here. So here I am given the view and that visibility boolean. And I can do something like this, like work out if the view is already in the end state that we want to get to, and if so, bail out of there fast. Otherwise, I can run a view property animation, in this case here, to animate the alpha. And with visibility changes, we know we don't want to just leave a button in the view hierarchy receiving clicks and so on with 0 alpha. We want to set its visibility to gone, so it doesn't have any of that. So here I'm using an end action to do that. So this will essentially achieve what we wanted. This will give us this animated change. But there are a number of problems that you have to kind of be careful of or watch out for when you're doing this kind of binding adapter. Here's an example of one of them. When I first launched the screen, hopefully you can see that the progress indicator was just visible slightly for a moment there. You've got to be really careful about making any assumptions about the state of the world when you're running these animations. You need to be careful that you're properly telling it when to run the animation and when not to. And that can be hard to be done just in the view layer. So instead, one technique that you can use is to move that to the thing that does know what state you were in and what state you are moving to, which is the thing which will produce this UI model. So normally in most of these architectures, you have some kind of reduce function which takes the given state of the world and for an action, reduces those down to a new state. So this is the point at which you know about what state you were in, what state you're going to, and as such, you're best placed to model whether or not an animation should be run or not. And better yet, you can do this kind of diffing and so on a background thread or whatever it might be, and just emit the status for the UI to listen to and react to. So here I am adding this third property to my UI model, whether or not to animate. And I can pipe that through data binding with another attribute, whether or not to animate it or not, and pass it into my custom binding adapter. So then I can quickly check if you need to animate or not, and just set the properties instantaneously and get out of there. So hopefully that kind of establishes like some of these problems you have to be aware of. I actually want to flip it around and think about what properties we want to strive for when we're writing animations in this kind of world. And I kind of think of them as these kind of like three different types of problem that we want to strive for, types of solutions, sorry. The first is reentrant, which is a fancy way of saying you should be able to restart things at any time. Because essentially, in this world where we have this stream of updates coming out of our view model, they can come in at any time. So yeah, we have multiple values coming in. But if we're running animations, which take some time, obviously, to complete, we have to be prepared for a world where a new view state comes in at any time, as in when the animation is still in progress. This is why we need to be careful when writing our binding code in order to not make assumptions about values. Without that kind of world, you can end up with problems of continuity. So by continuous, I mean, let's take an example of this view here. So I'm simply animating the alpha when I touch it. So when I touch it, it animates from 1 to 0. When I let go, it goes from 0 to 1. But here I'm making assumptions about the value it should be at any one time. So if I let go and then press it, then let go again very quickly, you can see it jumps between the alpha values. Essentially, when you're animating something, you're looking for some kind of easing curve, right? You want to have a smooth change of the value over time. If you're making assumptions about this, you can end up with this kind of like discontinuous curve. So it was halfway through the animation, say the alpha was 0.5, and then suddenly a new state comes in, and you start animating back to 0. If you assume to have to start from 1, you're going to end up with this kind of jump. It's going to be really easy to write this kind of assumption into your code. If you've ever written code like this, where you just simply, doing an object animator of a view's alpha here. Here I'm fading something in, so I'm going from 0 alpha to 1. You should maybe consider if this is always what you want. If you want to assume about the start value, you can simply omit one of the values, in which case the object animator system will query the current value of the property. So here, the property we're animating is view alpha. That not only has a way to set that on the view, but it also has a way to query it. So if you don't provide the start value, just the target value, it will query for the current value and animate from there to your target. You could also look at using something like view property animator, which avoids this class of problem because it itself caches what properties are being animated and cancels any current animations and will animate from that value as well. So it helps you with this class of problem. And the third tenet of kind of animations I think we should be thinking about is making them smooth. So in this example, I'm simply animating this box to the top left or top right, depending on when I mash on these buttons. And there's kind of two problems you can see going on here. Firstly, if I do two animations to the top right, you can see it slows down and then starts animating again. This is because the normal Android animation system is all duration-based. So even though it's continuous, it's not jumping from one position to another, it is starting a new animation with the same duration. So say it was 1 second to get from position A to position B. Even if it's halfway through, when you start a new animation, it's still going to take that same duration. So you get a discontinuity in the velocity, as it were. The second problem this illustrates is if you retarget it. So here, when the box is going to the top left, and then I send it to the top right instead, it ends up having this kind of very jagged path like this. So it kind of stops and then reverses. And in the real world, nothing kind of moves like this. This doesn't feel very natural to us. So I think this is something we should strive for solving this kind of problem. And for this problem, I think there's a library which a lot of people have overlooked, which is the Spring animation library. One of the reasons I think a lot of people have overlooked it is because when you think springs, maybe you think of something like this. This is from our developer documentation, which shows kind of bouncy animations with these droids kind of like bouncing around. If you don't want a bouncy effect like this, then maybe you think springs aren't for you. But throwing that out, just because you don't want a bouncy effect, it actually kind of closes your mind to all the other things this library offers. You can actually control the bounciness with a damping ratio and turn it off altogether. And then you get some pretty interesting properties from a physics-based animation system, which are going to be useful for these problems we're looking at. So if, for example, we were to replace the duration-based animator system with a spring and apply it to this same kind of example, you can see here when we double hit the top right button, so when it's trying to have a new end state, it's doing it smoothly. You don't get this change in velocity. Or when you redirect it from one end to one side to another, you get this smooth path where it curves and maintains the velocity throughout the animation, even though you're updating it. So I think the spring system can be pretty interesting for solving this class of problem. If you haven't looked at the Spring animation system before, it looks API-wise kind of similar to the standard animator system. You create a Spring animation, give it something to animate, the property you want to set, an end value, and call start. The cool thing about the Spring animation system, though, is this API, I think, which has this animate to final position call. What this will do is if there is no animation currently running, it will just start it. But if there is already an animation running, it will maintain the velocity, the physics-based system behind it, in order to give you these properties we talked about, to continue the velocity or to gracefully change the direction or whatever it is you are animating. So I think this could be pretty useful for us. But the key is, let me go back here. The key is that calling this animate to final position means you need to call it on an already running animator in order to get these smooth updates. This can be hard to kind of like shoehorn into your architecture if we're trying to go for this kind of stateless binding code we talked about, where you're given a UI model and you want to animatedly bind it to your view. One technique I've been using is by packaging this up in a handy little extension function. So here I am adding an extension function to the view class, which will either create or retrieve a Spring animation. So the way I do that is this function accepts the view property. If you haven't seen this before, this is essentially, there's a bunch of different properties that the Spring animation library ships with for animating the standard things you want to do on views, like alpha, translation, X, Y, rotation, things like that. And then what I do is I store it essentially in the view's tag so that we can retrieve an already running animation. So I will get a key for a given property, just a simple kind of when mapping, and then check whether there's already a spring animation stored in the tag. If not, create it, otherwise, and store it, crucially store it in the view's tag, and if not, return it. So essentially this means get me a spring animation if it's already running, if not, create me a new one. And the cool thing I found with this kind of extension function is it makes the call site super simple. So just on any view, I just call spring of translation X, and then when I get access to this newly created or already running animation, you can call that animate to final position API. And it's kind of a neat way to tuck it away. So let's go back to our binding adapter example and take a look at what this looks like in this world. So here we are with the view property animator version. If we remove this and just use the extension function, we can quite simply animate in the alpha property in this example. But if there's one already running, we'll gracefully maintain the velocity of the alpha animation or retarget it and so on, like we talked about. The eagle-eyed amongst you might have noticed I kind of lost some functionality here. Before there was an end listener which was going to set the visibility. You can still do that, but it gets a little bit gnarlier with the API of the spring animation. Essentially, this is how you set the end animator, which is doing the same thing, which is going to remove itself and then set the visibility to go on. But we need to cancel any pending end actions before setting a new one. So if, for example, you're fading the alpha of a view from 1 to 0, you set an end action so that when it gets to 0, you set the visibility to go on. If a new animation comes in, so that you are changing it to another state, you want to get rid of that end action so it doesn't retarget the already running animation, but then still call the pending end action. So you need to remove it ahead of time. The way you do this on the Spring Animation API is you have to have a hard reference to the listener in order to remove it, so you need to store that somewhere. So again, I go back to the view tag, and I'll store that on the view such that I can retrieve it so you can remove it if a new update comes in. So a bit more work, but the thing I like about this technique is you can package up these binding adapters or binding code, whatever you want, into these like reusable chunks, and then use them throughout your application. So while you have to be careful when you're writing these binding adapters, you kind of write the 3 or 4 of them, or whatever it might be, to animate the kind of standard things, and then you can use them throughout. I slightly simplified some of the code before about creating a spring animation looking something like this. You normally want to set up the animation as well. So just like when you're using a normal animator, you'll probably want to set the duration or the easing curve using an interpolator. Similarly, for springs, you probably want to the 2 things you can control are the damping ratio and the stiffness. And you do that by customizing the spring force, which is the physics system underneath the dynamic animation. So what do you set them to? If you don't set anything, you get the default values, which is this medium bouncy, medium stiffness, which can feel not quite right for like common UI work, like fading things in and out or translation XY. What I found is there's some pretty sensible default values you can use, which generally work quite well. So by using this no bouncy, I just completely turn off that springy effect. So I'm not using the kind of the underdamped spring effect at all, and I'm setting a default stiffness. And that works really nicely with my extension function, because I can use Kotlin's default parameters to say, this is the defaults which I generally want, but I can just provide alternatives at the call site if I want to change, say, the stiffness of an animation to make it slightly snappier or slightly looser. And to give you a final example of this system in work, I'm going to take a look at Recycler View's item animator, which out of the box uses the standard animation system. So here I'm simulating, some objects being moved around just by the shuffle button. And you can see here we have that problem of not being very smooth that we looked at before, where things are reversing direction and velocity isn't being maintained. Subbing this out for a spring-based system, hopefully you can see you get a much smoother result. If you take a look at the box in the top left, which kind of goes to the right and then gets diverted to the left, hopefully you can see it moves in a much smoother way. And while these techniques might seem like micro-optimizations or something, this is probably representative of something happening in your app right now. I mean, how many people's apps out here basically grab some data from the internet and shove it into a recycler view, right? Recycler View does a lot of things for you using diffutil and so on. It'll diff it and run fine-grained animations, so only the right things kind of get updated or moved around. But what's the point in doing all this work if then the animation isn't as good as we can make it? Using a system like this, you can have these updates kind of gracefully animate around. And this was pretty easy to add to Recycler View's default item animator. Essentially, I extend that class and replace some of the animations for the move, which essentially sets up the move by setting translation X and Y on individual views and then animating those values back down to 0. So here I overrode the kind of move item method with my own version, which uses that Spring extension function and calls that animate to final position. So what that will do, again, is either create a new animation or retrieve a currently running one and retarget its value so you get that smooth behavior. So that was a technique, I think, which can be pretty useful for this kind of new world of animations. But I also want to highlight a few classes that Android ships with that can help you build these kind of systems as well. The first is a way to animate drawables in this kind of stateful way. So hopefully everyone is familiar with this kind of a stateless drawable, where you can provide different drawables given a state. So in checked, use this drawable. In not checked, use this other drawable. But I don't think as many people are familiar with its animated cousin, the animated stateless drawable. So this gives you a very similar API, where you can define static drawables in given states. But you can also define transitions to be run when moving between those states. So in this example here, when you're moving from the unchecked to checked state, you can provide a drawable, which can be either an animated vector drawable or an animation drawable, the kind of ping sequence version, which will be run when you are moving between those states. So this class is essentially a finite state machine, right? You give it the finite states that you expect your views to be in, and then transitions to move between them. And the great thing is that because this comes out the box from Android, it does all the reentrant stuff for you, right? It manages the state, and if the state changes, it kind of hangs on to stuff. So essentially, you can use it very easily. So you create this animated stateless drawable and the animations, the transitions between the states you want to support. And then the call site is super simple, right? You just set the drawable to this animated stateless drawable, and then you just set the states. So you're just saying checked, true or not, or true or false. And it manages for you running the animations. Your code becomes very, very, very clean. So we use this code in the Android Developer Summit application, a fork of the Google I/O application. So hopefully you can see it here. Just when you're starring or not starring, you get this animation running between the states. But you can use the same technique in a bunch of other places as well. So here's an example of the bottom navigation view, which basically sets the state of these icons, these menu items, to selected or not. And you can run a transition using this animated stateless drawable system when moving between them. So you get these kind of fun little animations as you change between the sections. So super simple to do. Each of the menu items in the bottom navigation view points to an animated stateless drawable, which defines those two states. And you can take this technique even further. So here's an example, again, from the Google I/O application. I hope it's coming out there, yeah. Where we had a custom button letting you know whether you had successfully reserved a slot at a Google I/O session. So this is quite a key moment. If you ever attended I/O, you want to know whether you've got a space in that talk or not. So as such, we didn't want to optimistically update the UI and just, make it checked when you tick it. We wanted to actually do a network call, wait for the response to come back, and let you know whether, yes, you got your reservation to the talk, or no, you got waitlisted, and let you know if something was going on. So the way we implemented this is entirely declarative, entirely driven by this animated stateless drawable technique. So we have one drawable set on this fab, essentially, which knows how to animate, how to transition between the given states. You might be looking at this and thinking, hey, what is state reserved, state waitlist available? Those aren't states I've ever seen before, unlike checked or selected you might have seen in Android before. And this is because I don't know if many people are familiar with this technique, but you can add custom states to any view. So the way you do this is you declare the custom states much like you might declare custom attributes for a custom view. So here are the different states that we support, 6 different ones, each of which is a Boolean. And then to implement this, we actually packaged this up in a enum of the different states that this button can be in. Because essentially, whenever we move between one of these states, there's a few things we want to change. As well as running the animation, we want to change some text that can be shown with a button or the content description. So we package these up as enum values containing, critically, that first state that we declared in our custom attrs, and some other information. And then we extend app-compat image button, in this case. It could have been the fab class for some reason. And add a couple of things. First, we have a public property, so where we can set one of these enum values. And this, crucially, calls refresh drawable state. So this is your trigger into the view system to say, the state has changed, please update. And that, in turn, will run the transition when moving between those states you defined in your animated stateless drawable. And the other thing you have to do is you have to override on create drawable state in order to let the view system know what states you support. So essentially, you need to call through to this merge drawable states method and pass it. Here, that's the attribute value which we had in the enum, which if I expand it out is kind of an int array of the attribute value, something like this. So by doing this kind of custom view, we could create these custom states and have it all managed declaratively for us. One technique I wanted to share is that when you're looking at something like this, you could see there we had 6 different states when moving between the different states in the button. So you could think, isn't that like a lot of transitions which you might have to write? If it's basically a 6 by 6, so n by n, so is that like 36 different animations, I think, that you have to be able to move between? Sounds a little bit overwhelming. That's a lot of AVDs to make. So one technique that we employed was to say that we would always move through a given state. So what I mean by that is that we never go directly from state A to state B. We always go through a pending state, which, if you look at the animation here, is basically that outlined hourglass going round and round. So by doing that, we essentially half the number of, sorry, not half, we move it from n by n to 2n number of states that we have to support. So by saying in our business logic, whenever you click it, you always go directly to pending, and then when the server comes back, go from pending into the final state, and vice versa. We half that. If you're lucky enough to be min-SDK 23, you can actually reduce that in half again, because on the platform version of animated vector drawable, we support reversing animations. So you can set a flag saying reversible true, but unfortunately, not many people are in that world, so maybe come back in a couple of years for that. Another technique I want to make you aware of is that in this example, we were basically running this kind of pending animation, this animation that loops while we're waiting for the server to come back. There's a few things you need to be aware of, which is essentially that animated vector drawables currently don't support repeating animator sets. So when you're structuring your animation, you have to be a bit careful to make sure you can design them in such a way that if you want to have this kind of technique where you end up on a repeated animation, that you structure it such that the animations, only object animators basically can be repeated like this. So, going from one state to another, it animates some of it and then ends up at this kind of code here where it has a repeating animation which will keep on running, waiting for the next state to come in. So taking a quick look at animated stateless drawable and looking at the kind of principles we were looking for, unfortunately it only supports one of them. So basically it will do the reentrant thing for you. It will manage for you what state you were in and move you into the new state without you having to do all that state management yourself. It isn't continuous, so if you're halfway through an animation and a new state comes in, it'll just run the transition straight away. It won't kind of like somehow start from halfway. And it isn't smooth. It's not going to maintain velocity or anything like that. But for a class which you get for free out of the platform, introduced in API 21, but is also in Android X, so it's backported all the way back to API 16, so you can use this pretty widely. I think that's a pretty good class to have in your toolkit. Similar to stateless animator, to animated stateless drawable is kind of the view version, which is stateless animator, which allows you to animate between states of properties within views. Here's an example where I've used it in an app I work on called Plaid, where essentially when you select a comment on this screen here, you can see, hopefully it comes across, we're doing some things. We expand it out, but also, crucially, the view, we animate the background color and the elevation property. So rather than having to maintain that all ourselves, what state were you in, what state are you going to, we do this using this stateless animator class, which does a lot of the stuff for us. So it's an attribute you can set on your view, just like this. And it, a stateless animator, points to a selector. I don't know why it's not an animated selector, but it's a selector. Where within each item tag, where you define the states, you can supply an object animator or a set defining the properties to run for you. So here I am saying that when you go into a certain state, I want you to animate the background color and the translation Z, and vice versa when you go back into the default state. So this is nice in that, this is very declarative. I don't have to maintain those states myself. I just basically set a state for me. And here I'm using one of the default Android states I've activated, so I didn't have to go through the hassle of creating, state comment selected and all that jazz. There are a few states that you can reuse from Android, like selected or activated, and use those in your domain code to just set this kind of custom, non-custom state on the view. So let's look at stateless animator. How does it perform on those properties I want of my system? It is reentrant, so it will manage, if you changing state, it kind of cleans up after itself nicely and will just run the right animation for you for a given transition. I've given continuous a question mark here because this kind of comes back to the problem we saw before, where you can write these object animators in a number of ways. You can provide it a from value and a to value, or you can omit the from value, in which case it will do as we said before and just query the given value for a property and run an animation from there. So if you omit the from value and just give it a to, it will kind of give you this continuous property, but only if there is a getter for the property, because this is kind of like a reflection-y type system here. You can see that in this example here, for example, translation Z, I'm animating. It has both a get translation Z and a set translation Z, so this will work by omitting the from value. But unfortunately, views background color property, which is essentially a convenience method which creates a color drawable and sets it for you. There is a set background color, but there is no get background color. So if you were to try and use this without a from value, it wouldn't get that continuous property. It wouldn't be able to query for the given the current value in order to animate from there onwards. So I'll give this kind of like a 50% pass mark on the continuous property. And the next technique I want to talk about is something to do when you're doing custom view animation. So going back to the I/O app again, we have this kind of filter screen which lets you filter down the overall schedule to just the Android sessions that you really care about. And when you're doing this, there's a couple of things going on. This is essentially a custom view running a bunch of animations. There's the circle, the kind of like the color circle kind of expands and its center moves towards the center of the overall chip. And the text moves, and the icon on the right, the little X, scales up and so forth. When you're writing a custom view like this, you may be tempted to do something like this and create animators for each of the properties that are changing. So you might have one animator for the radius of the circle, one animator for the center of the circle, and so on and so forth. Instead, what I'd recommend is you do look at something like this, where we have one overall progress value. So this is just a float between 0 and 1, which we use to drive the entire progress of the animation. So when you change a state, you just animate it between these kind of 0 and 1, or you probably should omit the start value there. Oops. And then in our drawing code, what we do is we use that progress to then calculate the drawing for a given progress. So where should the circle radius be if we're halfway through the animation? If you're not familiar with this lerp function, which is linearly interpolate, pretty common function in animation, it basically just says for a given amount of progress between 0 and 1, between a from value and to value, what should my current value be? So the really nice thing about this is that we can then expose this one progress property and use that to drive the entire thing. So we could then drive this with a spring animation, like I talked about at the start of the talk. So you can make this completely smooth and respond to like a physics-based force system. Or you could hook this up to a gesture listener or motion layout or something like that and have something else drive this progress value between 0 and 1. So by having this one progress value you can animate rather than having to string together lots of animations into, say, a set of animators, you can then directly control the progress through it. So those were some techniques I think can be useful in this kind of new world of animation, that how we can adapt our animations to survive this change in architecture. And I kind of like propose these 3 tenets, but really it's kind of an ordered list, or like Crafty's hierarchy of animation, as I like to think about it. The first one, of the property of being reentrant, is kind of essential. I think in this new world where new UI models can get published at any time, if you don't support this property, basically your views are going to be broken. They're going to be in the wrong state. If you try and add animations in without thinking about this property, you can end up in a bad way. So I think this is kind of the basic level that you need to strive for. After that, I think continuous is a nice thing to have, and it avoids those jarring changes when a value jumps suddenly and unexpectedly. And so we can make the animation feel a lot better, but not as important as kind of entirely breaking it. And I kind of think of this smooth property, this kind of like physics-based system which smoothly updates, as kind of like the self-actualization, the top of the pyramid, the kind of something to strive for, because I really think it can make your animations much better. And that's all I got. So thanks very much.